All right, so section 6.1 deals with roots and radical expressions. All right, so the notes have a lot of variables in them. Okay, it starts out by saying A and B are real numbers and N is a positive integer. So when we're looking at this, okay, A and B are just regular numbers and N is a positive integer. So no negative exponent right there. All right, just a positive. And then it goes on to tell you that this means that A is an nth root of B. Okay, so if we put some numbers in there to help you understand what that's saying. So if we have 5 squared equals 25, then we know that A, 5, is the second root of 25. Okay, probably should have written that differently, but 5 is the second root of 25. Well, we usually don't say second root here. We usually say square. So if I say it again, 5 is the square root of 25, then that makes more sense for people. We know that you take this times itself and get 25, then 5 is the second root, the square root of 25. So that's what this first line says. Now we go into some other things. We're talking about all of our real roots. Okay, if it wants to know what all of our roots are, all of them, then if n is odd, so if the exponent is odd, okay, so right here, if we have a root, if that's an odd root, then you're only going to have one real root. If your exponent here or your power, your root right here, if that is even, then you're going to have two real roots. The reason why is if I put a box right here, okay, kind of going back up to what we have there, and I said, hey, what numbers could you plug in there to make that true? Well, we could plug a 5 in there, because 5 times 5 is 25. We could also plug in negative 5, because negative 5 times negative 5 is 25. So there are actually two real roots that make this true. Okay, so there are two options when you're talking about the second root of 25. Okay, we've got two possible answers. All right, now, since the positive version is more popular, it's what we tend to use, we call it the principal root. Okay, so the only time we'll actually care about the negative root of an even is when you're trying to solve for something. And you've seen this before when we've done this. Okay, when you're trying to solve for x to get rid of the square, we square root it. But when you go to the other side, not only do you have to square root it, but you have to put the positive negative. And that's how we get the two answers. Okay, so that should look very familiar to you. All right, and I've told you in the past that if your problem starts out, if I just say, hey, find that answer, then the answer would just be 5, your principal root. But if we're solving an equation for an even root or an even power, if we're solving for that, you'll end up having a positive and a negative version. So you'll have two answers. Okay, this one's the principal, so that's why it only has one. So it depends on how it starts, okay, and what it's asking for. So that takes care of the first part of the notes. Well, almost. Let's see. It also talks about, this line here talks about something we already know, that if B is negative, so B is what's on the inside. Can you take square root of a negative and get a real number? No, so you can't do that one. Okay, so if it asks for the real roots of square root of negative 25, there are none. You'd have to do imaginary for that to work. All right, then the last part of the notes, it's just telling you how to simplify this. All right, so when we simplify, when this root, when n is odd, okay, you'll only have one you just have that answer. You'll just simplify like normal. But if n is even, we may have to use absolute values. So we'll talk about that here in a second too. All right, let's start in with number 1. It says find all real square roots. That's what the directions say up here on number 1. Okay, so let's just make a little note, which is good to make on your paper for later. All right. So if they're asking for all real roots, if they're asking for all real even roots, so if the root is an even number, then you will have 2 solutions. Okay, 2 answers. If they're asking for all real odd roots, you'll only have 1. And what that means is, let's do a couple examples over here to get an idea of what's going on. So if we're talking about square root, actually, hold on, back up. Okay, we've talked about if I want to find the real roots of 25. Okay, we've talked about that one already. So this number 1, we know that all the real roots of 25 would be a positive 5 and a negative 5. So we've talked about that. Okay, so that's 2 roots. We're finding all the real square roots. So 0.16, 1600 would be the same kind of idea. You're going to have a positive version and a negative version since we're doing, square roots. This is the second root. And that's an even root. So we're going to have 2 answers. We'll have a positive and a negative version. So if you type in square root of 0.16, you'll get 0.4. So that means we have a 0.4 and a negative 0.4. Because 0.4 times 0.4 is 0.16. And negative 0.4 times negative 0.4 is also 0.16. So these are your roots, your square roots of what we started with. All right, so then what is the square root, or what are the square roots of negative 64? Okay, so if you're trying to think about this, this is what you're trying to find, the positive and the negative version. So we want to find all real square roots. Will this produce a real square root? No. If you want to take a square root of a negative, you're going to have to deal with imaginary numbers, but it specifically says real right there. So those are your answers for 1, 2, and 3. You're just taking square roots, realizing that if you're naming all of the real square roots, there's also a negative version. All right. The next part, numbers 4 through 6, we're going to simplify these. Okay. Now, this one right here doesn't show a number, so that means it's a square root. This one doesn't show a number here. That means square root, because those are the 2, that's the most common. But if they want to find the 3rd root or the 4th root or so on, they'll put a different number right there. Okay, so what you're probably just trying to figure out what I'm talking about there. If we have 3 squared, we get 9. So that tells us that the square root of 9 is 3. We can work it backwards. What if I wanted 3 to the 3rd? 3 times 3 is 9, times another 3 is 27. Well, if you want to work that backwards, you would have to, since this exponent was a 3, that means the 3rd root of 27 is 3. Okay? If you wanted the 3 to the 4th power, that's 81. So if you want to work it backwards, since that power is a 4, that means the 4th root of 81 is 3. All right, so when we're simplifying this, like this one right here, the 81, if you did a factor tree for that, if I told you to simplify the 4th root of 81, this would be the factor tree. So if we're doing a 4th root, we have to have the same number listed 4 times for it to come out once. Just like last semester when we did a square root of that. Well, if you do the factor tree, for you to be able to simplify this, the same number has to be multiplied twice for it to come out once. So since this was a square root, like what we did last semester, you need 2 of these for it to come out as 1. Okay, so that's kind of what we're getting ready to do. All right, so let's get rid of some of that stuff. So we can focus on 4, 5, and 6. All right, so we're taking the square root of 9b squared. Okay, so if we're going to look at 9, we're going to do a factor tree, and we get 3 times 3. So I'm going to rewrite this as 3 times 3, and then b squared breaks down to b times b. So since this is a square root, for things to be simplified, to come out of the radical, you have to have 2 of the same thing being multiplied. So we have 2 3s, so that comes out as a 3. And then here we have 2 b's being multiplied, so that comes out as a b. So square root of 9b squared gives you 3b. Square root of 9 is 3, square root of b squared is b. Now there's a little trick to this though. I told you that when the radical is there to begin with, okay? When that happens, we're only concerned with our principal root, okay? Which means when you're taking a square root or a fourth root or a sixth root, an even root, when you're taking it, you have an even root here, and this number right here is even, then that basically means your answer has to be positive. When this is an even number, this even root, when we have that, our answer has to be positive. So when you look at 3b, if someone decided they wanted to plug in a -1 for b, our answer would no longer be positive. Because of that, we also have to put absolute values around that b. That will make it positive. Okay, so when you have an even root, you might have to have absolute value symbols in your answer somewhere. All right, so we'll talk about that again. On number 5, we're doing square root of a to the 8th, b to the 18th. So if you factored all of this out, a to the 8th, you want to look and see what that looks like. Okay, I've got 8 a's here. All right, since it's a square root, a second root, it takes 2 of the same thing being multiplied to come out as one of them. So if you're taking the square root of a times a, that comes out as an a. There's another a times a, so that comes out as an a. This one comes out as an a, and this one comes out as an a. So that will give you a times a times a times a, which is a to the 4th. So look at that pattern here. When you have 8 a's being multiplied inside, you have 8 of the same thing, and you're taking the square root, it comes out as a to the 4th. So then using that pattern, how we could get the 4, okay, what happens with the 18? What will you get? What will it be? B to the what power? Okay, so kind of keep track that for every 2 b's, you pull one out. So if you have b squared, you get 2 of them, comes out as 1. Another b squared comes out as another one. You keep going till you have 18 of them. All right, so that ends up being 9. So this first one here is a 4, and that's a 9. Okay, so now, since it's an even root, we have to figure out if we need any of the absolute value symbols. All right, so if you plugged in a negative number for a and then took it to the 4th power, so a negative times a negative times a negative times a negative, would that be a positive or a negative? Well, that would be a positive. Anytime you take something to an even power, you'll always get a positive. So we don't need absolute values there. But when you take a negative to an odd power of 9, that could produce a negative number then. So this part has to have the absolute values. So the way to remember that, this only happens when the root is even. That's the only time you'll have to deal with absolute values in your answer. And if this is even, you'll use it when this exponent is odd. All right, number 6. This is a third root. Now, when that root is odd, you don't have to worry about absolute values, okay? So if we take negative 125, and we got to figure out what do we multiply them by to get it. So let's start with just the 125. If I do a factor tree, I get 25 times 5, and then the 25 breaks down to 5 times 5. So if we rewrite this, we know that 5 times 5 times 5 gives us 125, but we want it to be a negative 125. So 5 times 5 times 5 is a positive 125. How do we make it a negative? Well, negative times negative times a negative. So if all three of those are negative 5, you multiply them together, you'll get the negative 125. So if you have an odd root out here, it's okay to have a negative inside. And if you have a negative, or if you have an odd root out here with a negative inside, each number is going to be negative. All right, continuing, we've got a to the third. So this is how you would factor this out. So the only way we can simplify, since this is a root of 3, then we need 3 of the same thing to be multiplied together in order to pull it out of the radical. So this one, here we have 3 of the same thing, so we'll be able to pull it out there. And here we have 3 of the same thing, and nothing's left inside. So that's going to be your answer. You don't have to worry about absolute values when the root is odd. All right, so let's just look at number 9 real quick also. Number 9, a number has only one real nth root. What can you conclude about the n? Okay, so they're saying that your answer, okay, you just have one answer basically. You took whatever power it is, whatever root it is, and you got one answer. So what do you know about your n? Well, if you only got one real, then that means n had to have been odd. Okay, so that out here had to have been odd for you just to get, for you to have one real. Okay.